Okay, so I'll be trying to do an unconventional approach in this tutorial on neural networks. So before we start to do anything remotely related to neural networks, I think it is important to get some mathematical concepts right. This will build the fundamentals as we move on and do more complex machine learning algorithms. I'm going to begin by talking about optimization algorithms. So these algorithms basically do two things. They want to find the maxima or the minimum point of a function. So here in this tutorial, we'll be focusing on finding the minimum point. So optimization algorithms occur in everyday life. For example, when you commute to work, you always want to find the shortest possible path to get you from one point to another. This occurs in nature as well, in physical systems. For example, when you place a magnet in a magnetic field, you find that the bunch of magnets aligns itself along the direction of the magnetic field. And the reason why they do this is so that they minimize the total energy of the system. So this is an example of one-dimensional minimization. It's considered one dimension because the function f of x is only dependent on one parameter x. So the point of the algorithm is to find the minimum point x where f of x is basically the lowest. And you can see the red crosses, which is basically the path taken to minimize the function. So this can be done in two dimensions as well. And it's considered two dimensions because the function f is a function of x and y. And we want to find the coordinates x and y where the minimum occurs. So this circled cross here is basically the local minima. You can see that there are two minimum points in this graph, that local minima and the global minima. And we'll talk more about that later. Okay, I will describe a procedure of finding the minimum point of this function, which is x squared minus 2x plus 3. So what we want to do is to find the value x, which minimizes the function f of x. So I'll be describing an iterative procedure, and it's called iterative because we repeat the process until a certain terminating condition is met. This method starts by picking a random point on the function, and we need some way to update this point in the next iteration such that it will be closer to the minimum point. And the next iteration it will go closer and closer and closer again. So the method that I've just described is called gradient descent. And the update algorithm for gradient descent is as follows. X prime equals x minus eta, which is the learning rate, multiplied by the gradient df over dx. So the learning rate eta is basically will tell you how much you want the algorithm to learn. If eta is a large value, you take a step towards the right direction quicker compared to when learning rate is a small value. But then again, you can't set eta to be very high because this will cause problems in the algorithm. So this looks daunting at first sight, but let's break it down further. So you can see if the gradient is positive, if you choose a starting point where the gradient is positive, when you calculate eta multiplied by the gradient, you get a positive number. This means that x prime, which is a new value of x, will be equal to x minus a positive number, which will give you a smaller value compared to the previous value of x. So this means that x will move towards the left, which brings you closer to the minimum point of x. So now let's say you chose a point here where the gradient is negative. Eta multiplied by the negative gradient gives you a negative number. X minus a negative number is a positive number, which means that x prime is larger than the previous value of x, which means the next value will be towards the right, which again brings you closer to the minimum. So this, although it's in 2 dimensions, it generalizes to n dimensions minimization. So one problem we have in the iterative algorithm is trying to estimate the gradient df over dx. So this is simple from the previous example when your function is easy, like x squared minus 2x plus 3. But what if your function is something unknown? You need a way to estimate the gradient. So what I'm describing here is called the forward difference scheme, which basically is a simple way of estimating the gradient at f of x. So you can see here, you just choose a small value delta x, and you find the function value at f(x plus delta x). Then you just subtract it by the value at f of x and divide it by delta x. So by doing this, what you get is the gradient of the pink line, which is an estimate of the gradient at the position x in the function f of x, which is the first red cross you see here. So as you can see that the difference of the gradients is quite large in this graph, but as you make delta x smaller and smaller, your estimation will become more accurate. Okay, now that we have all the components to do the algorithm, I'll be talking about the logical flow to make it clearer. So the first step, you choose a random value of x on the graph f of x. You calculate that value. Then you update x with the equation x prime equals x minus eta times the gradient df over dx. And as mentioned in the two previous slides ago, this works for both negative and positive gradients, so it doesn't matter which starting point you choose. Next, you check if the percentage difference of the new value is smaller or equal to the threshold. So this threshold is basically something you set yourself. For example, if you set the threshold to be 1%, which is 0.01, you check if the new value is 0.01 times smaller or bigger than the old value. So what this means is that you basically just terminate the algorithm if the new value doesn't change much compared to the old value. This means that your minimum point has been reached. So if the value is not smaller or equal to the threshold, you just repeat the steps over and over again until you reach the terminating condition. And that's the end of the first tutorial.